presentation on two special cases for factoring. The first one is called just perfect squares, I guess. Perfect squares. I'm going to take a perfect square, and I'm going to use two variables, x plus y and squared. This is a perfect square. I want to look at what this looks like. I'm going to write x plus y times x plus y, and I'm going to FOIL it, and I go x times x times y, which gives me x squared plus xy, and then I'm going to take y times x, or xy, plus y times y, which gives me xy plus y squared. If I combine these two like terms, I have x squared plus 2xy plus y squared. Notice here that this is a perfect square. This is a perfect square. And this middle term is double the first and last number. First and last number. If you are asked to factor something and see something in this form, perfect square, and double the square root of each of these numbers, and I'm going to give you a couple of examples here, then it's really easy to factor. For instance, factor four x squared plus 12x plus 9. Now, you look at this and you say, perfect square, that's 2x. Perfect square, that's 3. 2x times 3, 6x. 2x times 3 equals 6x. If I double 6x, I get 12x. This is easily factored, 2x plus 3 squared. All right? That's all you have to do. If the first one is a perfect square, the last one is a perfect square, and the middle is double the two square roots. Now let's look at another one. We'll go with 25x squared minus 70x plus 49. All right? Perfect square, 5x. Perfect square, 7. 5x times 7 is 35x. Double it, I get 70. This is in minus sign. So when we factor it, it becomes 5x minus 7. Now if you wanted to check it, squared. If you wanted to check it, you could go 5x minus 7 times 5x minus 7. 5 times 5 is 25x squared. And then minus 35 minus 35 minus 70x and plus 49. You could check it if you wanted. No reason to. These are our answers. This is the first perfect special case. If you encounter this, and you will, it's really easy to factor. The second one is called the difference of perfect squares. Difference of perfect squares. That's where we have two perfect squares, and we're taking the difference of them. For instance, 4x squared minus 9. Perfect square, 2x squared and 3 squared. These are the square roots. So when we factor this, we have a 2x and a 3, and a 2x and a 3. And when I go like this, they have to be opposites because I have no middle term, so I make it a plus and a minus. 2x times 2x, 4x squared, 3 times 3 is 9. Because it's a negative, we need a positive and a negative. And then our positive 6x and our negative 6x cancel. Again, with the difference of perfect squares, you don't really have to think too much about it. If I had 25x squared minus 1, perfect square, 5x. Perfect square, 1. 5x and 1. 5 times 5, 25. 1 times 1 is 1. Because it's a minus, we have a plus and a minus. And there's no middle term. There's no x term. Positive 5x minus 5x cancel. We're good to go. Let's factor this last one. 49x squared minus 100. I'm going to let you try to do this. So pause this for a minute, factor it, then check your answer. All right, let's see what you got. Perfect square, 7x. Perfect square, 10. 7x and 10. Because it's minus, we have a plus and a minus. And then these 70 and negative 70, of course, will cancel. If I gave you 49x squared plus 100, that's not factorable. You cannot factor that. This is only the difference, subtraction. All right, starting with tonight's homework, or today's homework, you will be encountering differences of perfect squares and perfect squares. These are factorable the way we've been factoring, but if you notice them, if you look for them, it makes your life a lot easier. All right, I hope this helps and have a great day.